Hi, I am Dr. Abhijit Muli, working as Assistant Professor in Department of Chemistry, Sadhguru Gadge Maharaj College, Karad. In last lecture, we have seen introduction about stereochemistry. What is stereochemistry? What are the projection formulas to draw organic compound and interconversion of these projection formulas into each other. That was the warm-up. Let's start the basics of stereochemistry. The first word comes into consideration is isomer or isomers. What are isomers? It is derived from Greek language. Isos means equal and eros means parts. So isomers from Greek language, equal parts. What are isomers? They are the compounds having same molecular formula but either different structural formula or different orientation in space. What are isomers? Isomers are compounds having same molecular formula but different either structural formula or orientation in space. If they are having same molecular formula but structural formula is different, then they are called as structural isomers because they are having same molecular formula, number of atoms in a molecule, but different structural formula, and if orientation in space is different, then they are called as stereoisomers. Let's see structural isomers. What are structural isomers? What are structural isomers? They are having same molecular formula but different structural formula. It is also called as constitutional isomer. It is also called as constitutional isomers. There are 4 to 5 types of constitutional isomer. Let's see what are the types of structural isomer. First one is functional structural isomers. What are functional structural isomers? These are the different compounds having same molecular formula but different structural formula. And what is the difference in structural formula? The different is change in functional group. For example, CH3, CH2OH, alcoholic compound, and CH3O, CH3 ethereal compound. Let's see, both are having same molecular formula, C2H6O. That means number of atoms in these two compounds are same. 2 carbons, 6 hydrogens and 1 oxygen. That's why they are called as isomers. But connectivity of these groups are different. Here, how is the connectivity? CH3, CH2OH and CH3O, CH3. And what is the basic change in these two structures? The basic change is functional group. Here, the functional group is alcohol. Here, the functional group is ether. That's why they are called as functional structural isomers. Both are having same molecular formula but the difference in structure is functional group. That's why they are categorized into functional structural isomer. Next one is positional structural isomers. What is difference in these compounds? Position of functional group. Functional group. For example, CH3, CH2, CH2, OH and CH3, CH, CH3, OH. Propanol and isopropanol. Here both are having same molecular formula C3H8O. You can see both are having same molecular formula. 1, 2, 3, 3 carbon, 3 to 5, 7, 1, 8 hydrogen and 1 oxygen. That means these two compounds are isomers because they are having same molecular formula. Now difference between these two are change in structure. Here the carbon chain is linear, here the carbon chain is branched. And what is the basic difference between these two structures? It is position of functional group. Here functional group is OH. In first structure it is attached to first carbon, while in second structure it is attached to second carbon. That's why they are called as positional isomers, positional structural isomers, because change is in position of functional group. Change is in position of functional group. Now third type is chain isomer, chain structural isomer. Here what is the difference? Difference is arrangement or chain of carbon atoms in a molecule. For example, CH3, CH2, CH2, CH3, N-butane and CH3, CH, CH3, 2-methyl propane. Here both are having same molecular formula C4H10. So they are isomers. Both are having same molecular formula C4H10, C4H10. But change is in its structure. Here the carbon chain is linear, here the carbon chain is branched. So what is the basic difference between these two structures? The basic difference is chain of carbon. Difference is chain of carbon. So they are called as chain structural isomers. Another type of constitutional isomer or structural isomer. Now next one is metamers. What are metamers? Metamers are isomers in which number of carbon atoms on both sides of functional group is different. Number of carbon atoms on both sides of functional group is different. For example, CH3, CH2, CO, 3-pentanone and 2-pentanone. 3-pentanone and 2-pentanone. Here this is my functional group, carbonyl group, ketonic carbonyl. In first structure, number of carbon atoms on left side of functional group are 2 and on right side of functional group they are again 2. In this structure, number of carbon atoms on left side of carbonyl carbon is 1 and carbon atoms on right side of carbonyl carbon are 3. That means both are having same molecular formula C5H10O. C5H10O. But difference is in structure. And again, what is the difference? Number of carbon atoms on either side of carbonyl carbon. So these type of compounds having same molecular formula but structural formula is different. And what is the difference in structure? The number of carbon atoms on either side of carbonyl carbon or either side of functional group are called as metamers. And last one, it is tautomers. Well known example for this is Stereoenol tautomerism. Rearrangement of a single proton in keto form and enol form is called as ketoenol tautomerism. For example, CH3. This is keto form. Rearrangement of only single proton gives you another form. This is enol form. This is keto form. Why it is called as enol form? There are two functional groups. This is for alkene, En, and alcohol, Ol. So it is called as enol form. These are the 5 types of structural isomers in which the molecular formula is same but structural formula is different. All they are also called as constitutional isomers. Now, what is the question? What is stereoisomers? Isomers having same molecular formula but different either structural formula or orientation in space. Stereoisomers are the different compounds having same molecular formula, so they are called as isomers. Same structural formula also, so they are categorized into stereoisomers. Here the structural formula is also same, but what is the difference? Difference is orientation of groups attached to your carbon is different in space. That's why they are called as stereoisomer. Now, stereoisomers can again be categorized into 3 forms. One is conformational isomers, geometrical isomers, and optical isomers. Stereoisomers having same molecular formula, same structural formula, but orientation in space is different, that are called as stereoisomers. They are again categorized into 3 forms. One is conformational isomer, another one is geometrical, and last one optical. Let's see what is conformational isomers, what are geometrical isomers, and what are optical isomers. Conformational isomers, isomers that can be converted into each other by rotation along formal single bond. What are conformational isomers? Isomers having same molecular formula, same structural formula, but different in orientation space, and these isomers can be converted into each other by formal rotation along a single bond. These are called as conformational isomer. Let's take example of ethane. CH3, CH3. Okay, how this ethane, in first lecture we have seen projection formulas. How this ethane can be represented in Newman projection formula? Like this. This dot represent my frontal carbon, its 3 hydrogens, and this circle represents the rear carbon and its 3 hydrogens. Okay, and I have mentioned the maximum distance. I have maintained maximum distance between all these hydrogens attached to frontal carbon and rear carbon. This is Newman projection formula for ethane. Now there is a single bond between these 2 carbons. There is single bond between these 2 carbons, and along this single bond these 2 carbons can rotate at any temperature. Now due to rotation of this carbon along with this single bond, different orientations of these hydrogens attached to this carbon gets there. Now angle between these 2 hydrogens, they get changed every time when your carbon bond rotation takes place. Now the angle between these 2 hydrogens is 60 degree. Maximum distance is maintained, maximum angle is maintained between each hydrogen. This isomer is called as staggered isomer. Now the rotation starts angle rotation of this hydrogen starts along carbon-carbon single bond. In one case, all these hydrogens, they eclipse each other. They come in front of each other. So we call it as eclipsed isomer. Eclipsed isomer, in which angle between these two hydrogens is 0 degree. So it is called as eclipsed isomer. And isomers produced due to rotation and creating angle between 0 to 60 degree, that is 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, 58 degree, 59 degree, all of them are called as skew isomers. All of them are called as skew isomers. That means 0 degree eclipse, 1 degree rotation of this hydrogen along the carbon-carbon single bond, skew, 2 degree skew, 3, 4, 5, until 59 degree it is skew isomer. As soon as it attains 60 degree, that is angle between frontal hydrogen and rear hydrogen attains 60 degree, it is called as staggered. And such type of isomerism is called as conformational isomerism. What are conformational isomers? Isomers having same molecular formula, same structural formula. Since the structural formula is same, they are categorized into stereoisomers, and again they are called as conformational isomers because they are generated due to rotation along formal single bond. That may be carbon-carbon, carbon-nitrogen, carbon-nitrogen-nitrogen, but isomerism generated due to rotation along single bond is called as conformational isomerism. Now let's move from conformational isomerism to geometrical isomerism. What is geometrical isomers? Isomers produced when there is restricted rotation along carbon-carbon. Isomerism generated due to restricted rotation along carbon-carbon bond. For example, well-known isomerism, cis-trans isomerism. Cis-trans isomerism. Here what happened? They cannot be categorized into conformational isomerism because there is restricted rotation along these two carbons. Why there is restricted rotation? There is a double bond. If this carbon tries to rotate along carbon-carbon single bond, the bond will be ruptured. The double bond, the pi bond will be ruptured. So the rotation gets restricted, and due to restricted rotation, the groups attached to these two carbons, they get locked in a space. In a space, they get oriented. In first molecule, these two groups, they are attached on same side of carbon-carbon double bond. In this molecule, they are on opposite side of carbon-carbon double bond. Such type of isomers in which there is restricted rotation. It might be due to double bond, it might be due to ring structure, but when there is restricted rotation, such type of isomers, they are called as geometrical isomers. Well-known example for geometrical isomer is cis-trans isomerism. Due to restricted rotation, the groups are oriented in space, they are locked in space. In cis isomers, the two groups CH3, they are locked on same side of carbon-carbon double bond. In trans isomer, they are locked on opposite side of carbon-carbon double bond. Then the last isomerism, stereoisomerism, is optical isomerism. They are the twins. They are having all the same molecular formula, same structural formula, but orientation in space is different. For example, lactic acid, in which the connectivity is also same, but what is the difference? They are mirror images of each other. Just like twins, they are mirror images of each other, even if their physical as well as chemical properties are also same melting point, same boiling point, same refractive index, same density, same solubility. But what is the difference between these two structures? Orientation towards plane of plane polarized light. If we pass plane polarized light through these two compounds, one of the compound will rotate your plane of plane polarized light towards right hand side, which is called as dextroisomer, and the another compound which will rotate plane polarized light towards left hand side is called as Stereoisomer. Dextroisomer and Stereoisomer, they are having same molecular formula, same structural formula, but orientation in space is different. Again, some of their physical and chemical properties are also same, but orientation of these two compounds towards plane of plane polarized light is different. One of them rotates plane of plane polarized light towards right hand side, which is called dextro, another rotates towards left hand side, which is called Leo, and both of them, they are called as optical isomers, since they are rotating the light in opposite direction and it deals with light, they are called as optical isomer. So this is the classification of stereoisomers into structural, stereo, conformational, geometrical and optical. And again, geometrical and optical isomers are also called as configurational isomers. Conformational isomers and configurational isomers. You can categorize initially conformational, configurational, then geometrical and then optical. This is all about isomers and its classification. Thank you.